All right, everyone. Welcome to tonight's Data Science DC meetup. We have Ramon Perez with us, who will be speaking about metric stores versus feature stores. So Data Science DC is part of Data Community DC. That's the umbrella nonprofit group that we fall under. We have a number of other meetups in the DC area. You can see some of the logos here and encourage you to check them out on Meetup if you're into other data type things. We're all part of the same Data Community DC. And you can see what's coming up on the datacommunitydc.org website. And you can check us out on Twitter, the Data Community DC. And that's how you can get in touch. So I want to say thank you to our sponsors, Prefect and ATA. Help us keep the virtual lights on. They're the folks who help provide the pizza in non-COVID times, and hopefully we'll be back before too long to also in-person meetups. But right now they help us keep the Zoom subscription. So thanks to Prefect and ATA. So Data Science DC is organized by myself, Tommy Jones, and Chris Smith. Let's see Tommy right here waving his hand at you. And if you want to get in touch with any of us, we have our Twitter handles there and also email addresses. So feel free to reach out to Jeff at datacommunitydc.org, Thomas at datacommunitydc.org, or Chris at datacommunitydc.org. We do have a code of conduct, and I won't read it to you here, but I encourage you to read it for yourself. The short of it is, please be respectful to everyone in the community. And if you observe behavior that is not in line with our code of conduct, please notify Tommy and myself, and we'll deal with it. We also have a diversity statement here for you. We want our group and our speakers and everyone who's involved to reflect the diversity of the community. If we were in person, this is the time where we'd ask you to look around the room and see faces from a very diverse group of faces. So we strive to keep diversity at the forefront of what we're doing and encourage you to make sure that is what we are doing. We have a couple of events coming up here. You might have gotten some pings today on your email if you subscribe to the Data Science DC meetup. On March 8th, I'm going to be talking about Python tools to deploy your machine learning models faster. April 12th, we have the winner of the text analysis interest group will be speaking. We don't have a title. That one's not up quite yet, but it will be shortly. And then in May 10th, we have scaling and distributing Python and ML applications with Ray. So a couple different talks coming up soon. We got more speakers even lined up after that. So looking forward to lots of great talks with the community in the future. And check them all out at meetup.com/data-science-dc. And we'll put that in the chat here. Also encourage you to subscribe to our YouTube. We do post events, the recordings of events there at youtube.com/datacommunitydc. So subscribe there. And join us on Slack. We have a Slack channel for Data Community DC. There you can interact with the community. And we have a link there that we'll also put in chat. And if you have announcements looking for a job, have a job to offer, internships, other events going on, other meetups you'd like folks to know about in the community, whatever it is, please feel free to share those in the chat at this time, and let's keep the community going here. And with that, I will turn it over to Ramon to talk about metric stores versus feature stores.
Awesome. Thank you very much, Jeff. Let me share my screen with everyone. So please let me know whenever you can see it. I'm also going to pop the link to the slides in the chat.
Looks good.
Okay. Everybody can see my screen, right? Cool.
Yep.
Awesome. Welcome, everyone. I'm very excited to do this presentation for you. Maybe some of you, or a lot of you, if not all of you, have heard about metric stores and feature stores. So I hope that by the end of this session, I can disentangle what these two means and what they do, and maybe even give you ideas on how they might help you in your workflow or at your organization. So to tell you a little bit about me, I'm currently a senior product developer at Decoded. We have global offices in New York, London, and in Hong Kong. And then also I help out in Transform, one of the first full feature metric stores. As a developer advocate, I've done a couple of talks for them and currently writing a blog post on the same topic for metric stores and versus feature stores. Before that, I was a data scientist at Coder Academy, a research associate at INSEAD, and I taught statistical programming at London Business School. Now, fun fact is that I used to live in Washington, D.C., and I was a researcher there, and I actually got a job and ended up moving to Australia through a job post in the board of the Meetup group. So this one day on 2019, I was looking for jobs, and then I saw the post for who was my former boss here in Sydney, and she was looking for data scientists to go to come here to Australia and help her build a data science bootcamp. I thought that was interesting. I was in the education and research space, so I said, why not? Talked to her, had a couple of interviews, and then ended up in Sydney, and have been here since. So amazing community. I value it very, very highly, like really get involved with people. One of the best parts about being in this area, in this industry, is really the community. So I cannot stress enough how cool it is to be part of the Data Science DC. So with that said, now let's talk about the agenda for today. So I'm going to talk about what are metrics, features, and what are their stores. I'm going to talk about why you should understand them and be excited about what they offer. And then I'm going to talk about how do stores add value, what solutions are out there, and how do I figure out what to look for in them. So let's get started with first, what are metrics and features and their stores. So first off, you've probably heard the phrase from Lord Kelvin that says, if you cannot measure, you cannot improve it. Usually when we think about metrics, we think of metrics because as something that we track because we want to, because we're pushing towards a goal. We have a milestone that we want to achieve, and metrics tell us how close we are to that milestone or to that goal. So what are metrics exactly? So you can think of a measure or something that companies use to measure, track, and improve the components that have a direct effect on their value proposition. And that can be many things, because the value proposition of a company could be what they offer to a client, what they offer to consumers, what they offer to a market, if it's a two-sided marketplace or if it's a three-sided marketplace. What is it that they provide back to the people that join them? It is also a standard for measuring or evaluating something, especially one that uses figures and statistics. So we think of a measure as an aggregation of several numbers based on time, based on characteristics, based on features. It's also a standard of measurement, and it's a quantifiable measure that is used to track and assess the status of a specific process. Now, that's all to say there's different definitions, there's different ways of thinking about metrics, but at the end of the day, a metric is going to be what's important to you, for you to track at your organization, to know that you're making progress towards X being something that is valuable to you. So there's different kinds of things. There's reports, there's monetary values, there's charts, there's clicks, there's relationships that counts as a metric, there's package delivery, there's different kinds of other tracks. And then there's also how fast do we deliver something, not just that we put it on a container or in a truck at X given day from the purchase order. So metrics are everywhere as well. So I mentioned there's dating apps, and you can think of a very frequently used metric for the dating apps as daily active users. How many days or how many users out of all of the users that I have log into the app on a daily basis. Premium memberships, you can think of churn. If you have a premium membership to Spotify, to Netflix, and so forth, you might be part of a model that detects whether you will leave that company or that subscription at any given point in time in the future. Then we also have clothing brands, and they might value customer lifetime value. If I buy a pair of jeans every 3 months or every 6 months from XYZ company or clothing store, what are the chances that I'm going to come back within a year or within the following next 6 months? Usually every clothing store, every brand has their own way of defining customer lifetime value, but that's just to say that is a very important metric. How long would you spend at my company before you leave us? or before you stop doing business with us, or before you can afford something pricier than us or nicer than us. News outlets, they look at web traffic, and that's very important for them. How many eyes do we have on our website at any given point in time? And then lastly, all employees, this is a non-exhaustive list, of course, should be tracking, or all employers should be tracking the happiness of employees. And that's a very subjective way measure. Every company will most likely define this in a different way, but it's just to say that that's also something very important for people. All right, so as an example, imagine that you own the bar. And some of the things that you think of on a daily basis are, okay, the signature cocktails of my bar usually improve much better the financial performance of my bar rather than when I sell regular drinks like beers or regular cocktails like an old fashioned, a Manhattan, or a regular margarita. I want to sell my consumers the best of the best cocktails that I've spent so much time working on. So if you think about it, you will get the following table on any given day. You will get 2 old fashions by this customer. These are all purchases that happen at one point in time. So you get an old fashioned, you get this shiny palace, the multi vodkatini. You can tell by the S or the last column that these are signature cocktails. You can see immediately in the price column that these are more expensive cocktails. So this will, in an aggregate sense, improve the performance, the financial performance of your bar. So you kind of want to push those a little bit further and a little bit further. You want to upsell those rather than upsell the beers, rather than upsell the regular cocktails. So you can see here, you have the crazy tiki tower, the banana-licious martini. I had a lot of fun coming up with these names. As you can see, the Caribbean sugar rum, watermelicious, Manhattan brown ales, and then you have different quantities for each. So you can tell that when you have a price, when you have a quantity, when you have a purchase at a given point in time, then you also have whether that was a signature or not. Now, how do you think about those metrics? So whenever you see people coming to your bar, the next thing you think of is, okay, who is, and the image, the cartoon caught off for a second. And actually this was made for this presentation, this cartoon. So when you're the bartender and you're thinking of the people that come to your bar, on one side, you're like, okay, please, I don't care how you look like, what you look like. I don't care who you are. Just order from the signature cocktail menu, because that's going to improve the financial health of my bar. I don't care what you look like, but you look very fancy. And why the hell are you ordering a beer? You know, so to speak. So you care about what improves the performance of your bar, and you want to be happy. So you always have those metrics. This translates to any kind of business. You always have those metrics in the back of your mind, and you want to work towards improving them. So the metrics you care about, they usually look like the following. So imagine the previous table that we had. So now we have everything aggregated towards the revenue per menu cocktail and revenue per classic drink. So as you can see, per classic drink or menu cocktail, and actually those two, forgive me there, I put them on the opposite row, the name. But essentially on the right hand side, you should see the menu cocktail, the one that we created, and then on the left hand side, you should see the classic drink, which clearly gives us less revenue on a daily basis than the one we want to see, than the signature cocktails. So a recent survey found, and jumping onto on the same topic, metrics are so important that a recent survey that asked participants, which of the following metrics do you track for teams that you support? What is important to you? We mentioned a couple for dating apps, for subscription services, for news outlets, but there's also active and engaged users. There's product usage. How many people are using a particular product of my brand? Because I might have people log into my account, but I might just have people log into my services or to my software just using a particular feature of the product. Another one is how many users do I have at any given point in time? What's the revenue? What is affecting revenue and what isn't? What's the user retention? I mentioned churn, revenue retention, and so forth. So we want to keep people in the app, but we don't only want to keep them in the app or in our services, but we want to keep them spending as well. I mean, that's the nature of business. We want to be profitable. So a quick note on the interchangeability of metrics and KPIs. There's a subtle distinction between the two, but you should know that both are used sort of in the same fashion in industry, but there is a subtle distinction. And for example, metrics are tied up to the success of your company. A metric is attached to the goal of your company. A KPI is tied to a specific goal. So for example, the success of an ad campaign. Ad campaigns come and go all the time. We could see at the aggregate level, what is the effect of all ad campaigns on the revenue of our company. But if we're talking about one specifically, maybe we're measuring a KPI. a performance indicator, a key performance indicator for that particular ad campaign. Now, metrics are data points aggregated over time. They can be aggregated over other things, but usually you want to see the trend. You want to see whether it went up, whether it went down, and how is the business going. KPIs are frequencies and aggregated numbers that provide direction towards achieving a goal. And then metrics are used to track the company's financial health, among many other things. And then the KPIs, they can change regularly for similar or different goals that may or may not affect your revenue. So characteristics of a good metric, what are these? So they have a clear goal. They are actionable. They are readable. So you can understand what a metric is. For in the example before, we were calculating how many cocktails in the signature menu we sold versus the regular ones. So they are readable. You can understand that this is the, you multiply, you get the product of the price of a cocktail versus how many of those you sold, and then you sum it up on a given day. They have a consistent definition, so their definition doesn't change over time. Or if it changes, it's because of a good reason. They are measurable, and they are relevant to the bottom line. So those are some characteristics of a good metric. Now that we know what metrics are, let's talk about the metric stores. So what's a metric store? A metric store is a tool that allows you to define metrics as code, govern them, and serve them to a variety of downstream applications. Let's unpack what that means. So you have some data sources, you have some data tables, some CRM systems, some data applications. They come to some databases. You have data everywhere. Then you have a data storage where you put everything so that your analysts, your data scientists, your machine learning engineers, and anyone that deals with data can access the data and then do something useful with it. Then after that, you have the metric layer. So your metric layer is sitting, or your metric store is sitting between your data storage and your data analysis and other tools. So your downstream applications. So the metric store is the place that you write the definitions of your metrics as code, you govern them, and then you serve them to your data analysis tool. Now, notice that this assumes that an ETL approach took place. And I'm not going to dive too deep into the topic of ETL, but ETL stands for extract, transform, and load. And that essentially says, I took the data from one place, or many places, I transform it into a way in which it makes sense for me and my business, and I load it into a data storage so that my data scientists and my data analysts, they can all take advantage of this. So metrics allow you to also productionalize data for different use cases and stakeholders at your organization. So for example, a finance team or a marketing team or a sales team, they have to go and access these metrics, but not all of them might be able to write code to define the metrics. While as if somebody else defined it for them, say a data engineer or a data analyst or a data scientist, they can always come to the catalog in a metric store and then just pull them up to Power BI or to Tableau or anyone else without having to write SQL code for it. So in this other instance, you can have the data sources, you can have the data storage, you can have a transformation layer, then you can have the metric store, and then you can have your data analysis too. Now notice that this assumes an ELT process. So we got all of our data sources, we pull them all into this data warehouse, optimized for analytics. When you hear the phrase optimized for analytics, that usually means that the format in which your data was saved, depending on the nature of the data, but most likely is in a columnar way rather than a row-wise way. And that means that it's easier to access it for analytical purposes. We can take the average of a column in one go rather than take the average of a column based on a row by row by row by row by transaction. So that's the major difference. But as you might imagine, these two might actually be part of each other. And they actually are part of each other in some tools, the metric store and the transformation layer. But it depends on the use case. And we'll talk about that more in a second. Okay, so what was it like before we had a metric store? Well, each use case will have its own metric logic definition prior to the analytics stage. So you will have your data sources, you will have your data storage, and then you will have the metrics logic very tightly integrated with your data analysis tool. So if you could think about writing a SQL query to access a database from Tableau, from within Tableau, or think about writing a SQL query from a Jupyter notebook using pandas from SQL or read SQL, I can't remember the exact name of the function, or think about Power BI or any other tool. You will write the logic to create your table or to create your data frame. You will bring it up to your tool, and then you will start doing your analysis. So what that means is that you will always have to rewrite or find the script to get the same table and to get the same definitions every time you were trying to do some analysis or build a dashboard or build something useful to make decisions on your organization. And I see a question here from Will. He says, so can a metric store just be a set of SQL views in a data warehouse? That is a great question, but it's a little bit more than that. Yes, and more than that. And I'll come to that here in just a second. So how do they work? And I hope I can answer your question here. So you connect to your to the flavor warehouse or database available at your organization. Your data producers define the metric as code. So here's the different thing. Like you can have a view of a SQL query, but are you always going to have that view of a SQL table as long as it's there? In a metric store, you define it and you have it there. You go and with the click of a button, you have your catalog and you can see the things that are available for you. So you have the data producers that define the metrics as code and in multiple ways. And then you have the downstream tools that connect to your store. So you have the producers, you have the store, you have downstream tools like Power BI, Tableau, Data Wrapper, and whatnot. Then you have all the SaaS applications to do analysis like Mode, Optimizely, Salesforce. Then you have for ML stuff, you have Hex, Amazon SageMaker, Jupyter Notebooks, Arch Notebooks. And then you have your different product teams. You have marketing, you have finance, you have sales, you have product. It does like anyone that can access, that need to access metrics can always go and find the same ones. Now, what are the mechanics of it? So I mentioned you connect to your data warehouse but then you have a framework. So there's different tools out there that do things differently, but mostly you either have a particular language to define the metrics. For example, this one is particularly to QJS, which is an open source framework built on JavaScript to create a metrics layer between your JavaScript or your front-end applications and your back-end applications and your warehouse. So this is one way. The most common way, or the one that I've seen most people default to, because it's easy, because it's a language, it's the way in which we create infrastructure, is the way in which we create a lot of things nowadays, is using YAML files. So this one is MetricQL, and this one sits on top of dbt. So if you heard of dbt, which is a transformation tool, or dbt core, this one sits on top of dbt core. It creates your transformations for you, and then it keeps a record of the metrics. So you can always, after they have been defined, you just need one simple query to, yes, dbt is awesome. You just need one simple query to go and access all of these tables. So then we have transform. Transform uses as well YAML files like MetricQL. They use YAML files, and then you specify who the owner is. You display the name, how you want to display the name of the metric, what kind of metric is, what kind of expression are you doing, and then you can also combine complex SQL queries within your YAML file. So all those tools, a lot of these tools are defaulting to the YAML format because it's easy to reason about, and you can apply version control best practices to it. So then you have the second piece that you have in the mechanics of a metric store is that you have a catalog. And then that catalog allows you to go and literally select what you have without having to rebuild it. So I mentioned that from a Jupyter Notebook or from a Power BI or from another tool, you will write your query, you will get your table, you will start doing some analysis, you will create a report, or you will create a dashboard, or you will use it for something else. But now, if you have a catalog, you don't have to go and create it again. All you need to continue using it is a metrics API, and not even. Because you might be able to just go to your catalog and get a CSV exported out or get something else exported out, and then you can just, off you go and you work with that. But if you have a metrics API, you can literally make a call, just send a request, make a call, and then you get the data that you want based on the specifications that you have. So this one is particular to QJS, again, an open source framework, easily available with a lot of tutorials that you can just go and follow. This one is for transform. You do a pip install transform. Then you set up with your API key, you set up your MQL, which is metrics query language. And then you say MQL.query revenue and country. You get a table based on those two queries, and you get a pandas data frame, something that most of you are familiar with. So then what problems do metric stores solve? And I mean, I'm sure you can see some of the problems that they solve already based on the previous descriptions, but let's talk about them in detail. Let's say, so the first one is inconsistent metric definitions across teams. The second one is wasted time writing queries and code while you can just go straight into the insights. Imagine having to write, if you have something, if something is different from the current query that you're about to write or the data that you need, imagine having to write that just completely new query to get data that is just slightly different. So the next one is inaccurate values at the time of reporting. If you, by any chance, computed a metric that is not the way in which, say, the finance team uses it, and this metric is related to revenue, well, I would much rather go with the finance team definition than with my definition, because they are the subject matter experts in that instance. So the other one is untraceability of code and queries. If every time we have to create a report, we write a SQL query and then we forget about it because we don't save it or whatnot, then who's going to know what query defined the data that we are reporting on? The other one is lack of governance and trust. Who created what, when, and how? If you remember in the previous slide, there was a name on top of the catalog that said this person created this. And then duplicate data. We don't want to be creating the exact same tables over and over and over at different teams. Well, we can just create it once and everybody takes advantage of it, which leads to increased cost in the use of cloud resources. If we all share the data and share the definitions, then that leads to less computations or running on the cloud or running on a server. So let's see, I think I have a question here. So Andres says, is the metric store a collection of metric definitions or a collection of calculated metrics? If the former, then why do we need to connect to the data? We can connect later. And if the latter, then what is the fundamental difference from the features? Okay, so I got a whole section dedicated just to the differences between the features and the metrics. So I'll answer your question there. I'll answer part of your question there. But the other one is that it is both. You can have calculated metrics on demand, and you can also just leave it there sitting with the definitions. I believe that depends on the tool. So for example, because you have to set up Cube.js in a way in which it stays running. So basically you have to set up a process, spin up a process and leave it there running. Then that also adds on how do you want to use it? How do you want to access? You can have both direct views of the metrics that you have already defined and also just the definitions there and then calculate them when you need them. That's my understanding of it. I don't have much experience with Cube.js. With MetricQL is in the same category. Because you have dbt at the bottom, you can already set, you have to run the transformations on dbt before you get to access your queries with MetricQL. And I just read this about a week ago. So it depends on the tool to answer your question. And then we'll get to the differences between both in a later section of the presentation. I won't spend months getting teams to agree on definitions for retentions. Yes, and that happens very, very often. So, okay. So then also part of the survey that I mentioned earlier, what would you like to achieve when reporting on metrics? So one of the things that people say, Angel, to go to your point, is eliminate ad hoc repetitive tasks, bringing more capacity to the jobs, or even democratizing access to metrics. So that ties to the definition, like, can we agree on a metric? How do we track it and whatnot? Increase trust and confidence in the analysis. That also ties back to, do we agree on a definition or not? And lower computational costs and so forth, democratizing access to metrics. So then who uses them? Well, Airbnb has Minerva, and they have a good set of posts that I highly, highly recommend. Describing Minerva I believe to this day, it is not an open source tool from Airbnb. I don't know whether they will make it an open source tool or not, but there are amazing blog posts describing exactly how it works. LinkedIn has just a tiny blog post about what they have, but they don't really explain, or I haven't been able to find much information about how their metric store works, but I do know that they put it out there, that they have one. Uber has Umetrics and M3, so they actually do have an open source version that you can use to track metrics. So I highly recommend that you check those out. So now let's talk about the features. All right, so what are features? So features are numeric representations of raw data that serves as the fuel of machine learning models. So what does that mean? So on the left, we have students, yes, no. Is this person a student? Is what month of the year is this one? What's their income? 20K, 75K. So these are not features per se, because they are not in a way in which a machine learning model could make use of them. Now, the ones on the right, they are features because they are numerical representations of raw data. So on the left, we have the raw data. And then on the right, we still have raw data, but we just have a numerical representation of the raw data. So now that we talked about features, and we'll continue expanding on that, why are they important, or what purpose do they serve in the machine learning workflow? Because metrics are very analytics oriented, company oriented, and so forth. Features are very, I belong to the machine learning workflow. So we have a problem, or we have a goal that we want to achieve. We have some data sources. We have to prepare the data. Then we have to create features. We come up with labels if they don't have labels, or we enhance those labels, or we get images labeled, or we get other things labeled, like pieces of text. What's the sentiment of this and whatnot? Then we train a model. Then we evaluate it. Then we fine tune it. Then we train it again. When we're satisfied, we deploy that model. When we deploy a model, we don't just stop there. We also monitor the model. And then once we are satisfied, we have a process, we have a system in place. We have a whole system set up for that machine learning workflow. Well, we do it all over again. We continuously improve it, because down the line, our models might suffer from distribution drift, or they might suffer from concept drift, or many other things that may happen. So Tommy said, metrics are company oriented and features are part of the machine learning workflow. Yes, that's exactly correct. So how do we create features? So by recoding all non-numerical values into numerical ones, like think, for example, the Likert scale in a survey. We turn those questions into numbers. So for example, we have, how satisfied are you with your chicken burger? Very satisfied, very dissatisfied, dissatisfied, neutral, satisfied, very, very satisfied. So then we have a representation of satisfied, dissatisfied. 4, 2, it depends on the person doing this. So that you might find it in many different ways on how they do it. Some people do it -2, -1, and 0 for neutral, and the latter two for, and the former 2 for dissatisfied side, and then 1 and 2 for the satisfied side. It just depends. Then we can also have, we can also extract information from different data points. So for example, if we have a date and time, a date time column in our data set, we can break it down into date, month, year, hour, minute, seconds. And there are many other ways. So that was the structured data, but what about unstructured data? So imagine we have a set of dad jokes. For example, how did the picture end up in jail? Well, it was framed. I made a pencil with 2 erasers, and that was pointless. Where do lizards go to fix their fallen tails? To the retail shop. So imagine we have some dad jokes. The way in which we would represent them to go into what is called the bag of words approach in natural language processing, or text analysis, text analytics. We will need a representation of every single one of the words and the frequency with which they appear in all of the documents or all of the dad jokes in our bag or in our data frame. And that is another way of structuring unstructured data. And that will be the features. So what is feature engineering? So feature engineering, now that we know what features are, so we know what features are, we know what the machine learning workflow looks like. We know how features get constructed into how raw data gets taken from raw data and then transformed into numerical features that can be taken into a machine learning model. Okay, what is feature engineering? Which is another step from the regular features, or what we see as raw data. So it is the process of formulating the most appropriate features given the data, the model, and the task. And this is from an excellent book on feature engineering by Alice Sheng and Amanda Casari, and I hope I'm pronouncing those two right. Excellent, excellent book. It is also using domain knowledge of the data to create new features that increase the signal coming from the data. So I put a little tool over here because feature engineering is as much an art than it is to some degree, well, it is a science, it is an art as well, sometimes coming up with clever features. It's actually ingenuity as opposed to just looking at what could you do at that given point in time with that feature. All right, so feature engineering is important because it helps us capture subtle to complex relationships in the raw data, increase the accuracy of our models, get rid of duplicate features. So for example, you might have the date in different formats in your same data set. You might have features hinting at the exact same thing. So meaning they are both correlated. You may have multiple features correlated with each other. In addition, it might reduce the magnitude and the scale of the features. It deals with outliers, and it reduces the dimensionality of our data. Sometimes we don't need all the features that we have or that we're using. Have you seen theories from social science or business disciplines used to develop features? I have. I cannot recall any from the top of my mind, but I mean, like I mentioned earlier, coming up with features is a bit of an art to some degree as well, but it requires, but most importantly, some of the most clever features require subject matter expertise of a particular domain. So I wouldn't be surprised, like social science and business disciplines can come up with a feature much better than somebody that has worked their whole life in pharmaceuticals or something like that. And I'm just picking an example off the top of my head. I could be completely wrong on that one. But how to select good features? Strive for simplicity. Simple models are easier to explain than complex models. Select independent features. Avoid useless features. So for example, if you have a data set where you are trying to determine whether you are going to provide whether you are going to accept a credit card application for an applicant at any given point in time, and you have a feature that says this is their zodiac sign, I mean, that's probably pretty useless. I feel like I've met people that would disagree with me whether the zodiac sign has something to play with that, but of course, take that with a grain of salt. That's just a silly example. So avoid redundant features as well. So if a feature that you have multiple times, say you have the price on one currency and then you have it in another currency, get rid of one and normalize it to one. Pick good starting point for the minimum number of features that your program will need. If you work at an organization where you have thousands and thousands and thousands of features, maybe pick, I don't know, 100, 150. Start building a simple model and then increase the scale of it. All right. So now that we know what features are, let's get to the last part before we go and talk about the differences and the similarities and the advantages and disadvantages of these two tools. So feature stores. What is a feature store? A feature store is an ML-specific data system that turns data pipelines that transform raw data into feature values, stores and manage the features data itself, and serves data consistently for training and inference purposes. This is by a great article called What is a Feature Store by William Penier and Mike Del Vaso. Mike Del Vaso is the CEO of Tecton, and William Penier, I hope I'm saying this right, but I think he's one of the co-creators of Feast, but I could be wrong on this one. But it's an excellent article that I highly recommend you to read. Okay, so what problems do they solve? So the lack of management on features and access to new ones, a slow online serving, streaming and real data or real-time predictions. Now, I want to make the distinction between the different kinds of training that there are, batch training versus streaming versus real-time. Those are all completely different, and those have their use case. But when I say slow online serving, it means that, for example, if I am an Uber customer or a Lyft customer, if I come into the app and I need to receive a prediction for how fast am I going to get from point A to B, well, Uber already has some information about me that might be going into a model, which means that what they need is where I'm going is the only new piece of information, but me or my characteristics are already sitting in a database. So the model, the feature store, has to go and get those features about myself, use them with the new information about myself, and then provide a prediction. So that's what I'm referring here with the a slow online serving. So serving my data for a prediction when I need something in return. Inconsistent data transformations, data pipelines, constant rebuilds. So avoiding that. The monitoring of feature pipelines, health in production, and then having to provide extensive engineering support. Okay, so how do they work? So again, we have a problem and we have a goal. We have to get the data to solve that problem, to arrive at that goal. But then we have online serving or online features or online data, and then we have batch data. But then we have the feature store in between those two, and we have a model. We have some data scientists collaborating with the model, collaborating with the training, the serving, the sharing, the monitoring, and so forth. And then we have the deploy model. So that, in a nutshell, is sort of how it's an abstract way, in an abstract way, how feature stores work. But how does the online work? So the online takes data from events, web applications, external APIs, and logs, and many other things that might be at your organization. Then the batch takes data from data warehouses like Snowflake, BigQuery, or the stuff that you get with BigQuery, with Redshift, Azure Synaptic Analytics, and so forth. So essentially, the batch is data, historical data sitting somewhere. Online data is data coming in or data that we need on the spot. So who uses them? Let's talk about who uses them. So Spotify has Jukebox, Airbnb has Zipline, and they all have articles about it. There's a great talk describing Jukebox on the Feature Store Summit from last year, and it's on YouTube, and it's very excellent. They describe exactly why it works, how it works at Spotify, and why they had to build it. Airbnb, Zipline, I believe they have a couple of blog posts on this. Gojek developed Feast, which is one of the first feature stores that are open source. And Uber has Michelangelo Palette. So there's quite a few companies that have had to develop this at their organizations, because it is a problem to serve these features online when you need them. So you can think of, say, for example, if you have built a model in the past and you have created the data transformation functions that when you pass in the data, a new user passes in the data, all of this data gets either transformed, tossed away, or sent somewhere else. And then you receive a prediction. Well, that is a new user. But then on the other hand, we have the users that have already been in the app, that have already been using our services. They need to, for us to be able to provide them with an online, with an in real time prediction, we require the new data that they are inputting into an application, plus the old data that we have from them. And that is what feature stores solve. They create this layer where we can access data as we need it on demand basis. So now let's go to why should you understand them and be excited about what they offer. So why do we need metric stores? So metrics are the shared language for an organization to make decisions on. We talked about this quite a bit. They allow us to measure and improve our business outcomes, track the evolution of our products and services, and then test the effects of new products and services in different areas of the business, and also to understand consumer behavior. Also to spot dips and spikes in performance and prevent churn and turnover. So essentially, churn is a very important metric, and turnover. We don't want our customers to leave us, but we also don't want to have employee turnover. So why do we need features? Well, to represent raw data from the real world, to train machine learning models, to improve our products and services with machine learning, and to understand customers' behaviors, to provide recommendations to consumers, and to provide recommendations to consumers. Sorry. And why do we need metric stores now? So now we know why we need metrics. Why do we need features? Why do we need the stores? Well, to standardize the way in which goals are tracked within the organization. I mentioned the importance of having a catalog, having somewhere that you can go and always see consistent metrics. Also, to apply well-tested software engineering best practices to our analytical functions. Think about having a file where you are describing not just your query, but also your transformation for that metric. So essentially, because it is in a YAML file, because it is in a piece of script, we can track that and we can apply software engineering best practices to it. Also, to let our visualization reporting tools do what they do best and move all the metrics logic into a single place. To stop duplicating tables at the warehouse level. So this answers one of the questions from earlier. Can I just have a table sitting in the database with all the metrics that I want? And you can, but I think the best explanation as to why that doesn't work was on the Airbnb's blog post about Minerva. They had these kind of tables sitting on the warehouse, but the truth is that anybody could go and change them, or some people could change them, some people couldn't. And it sort of became this thing, okay, who changed what and how and so forth. So you can create all these tables at the warehouse level that have all your metrics, but at the same time, you might be also duplicating them. And then because of the amount of teams doing and taking advantage of data analytics across the organization continues to increase. So you want to enable everybody to use metrics, especially those that don't need or want to code. All right, why do we need feature stores? So to reduce the latency between getting the raw data, transforming it, and making a prediction with it, to stop duplicating features for the same purpose, to automatically backfill newly selected features as needed, and to detect drift between data sources. Now, not every single solution out there might offer monitoring for feature drift or for distribution drift in your via your feature store. But just know that this is an option offered by some by some companies. Also, transformations might not be easily or readily accessible or available with a particular solution, but that is offered by paid services as well. So, and because serving predictions in real time is hard. So the advantages, we kind of touch on all of them. So this is just sort of a recap. You want to automate and the metrics and feature creation. You want to build trust among your users. So again, going back to that point that somebody brought a second ago, we couldn't agree for months on a metric definition. So here you have consistency, enable software engineering best practices, enable sharing the metrics and features across different teams, increase productionization velocity and experiments, automatically backfill metrics and features, and then increase consistency between training and serving data, reduce costs, abstract away complexity. Okay, can you explain detecting drift in the data sources with feature stores? Yes, so I haven't really delved that deeply into it, but my understanding on the feature side, at least, is that, for example, a distribution, you have a distribution for the historical metrics, and then you have the distribution of incoming features. If you have if you load the incoming features in batches, you can check the distribution of those batches before you put them in your data source, and you can compare the batch that you have collected from the online features, the features coming in, versus the distribution of the batch that is on your historical data set. If it differs by too much, then you might, I don't know if you are able to receive an alert, or if you are just able to see it in a dashboard, or whatever tools you have connected to it to check the logs of your feature store. So essentially it's checking batches of incoming data versus the batches used within your data. Because you are creating views of those new tables on the online side for serving, then you can see them easily in comparison to the previous one. So that also relies on what tools you use right next to it. No problem, Mariah. Okay, so the disadvantages. Advanced level engineering is required to set up, at least from my point of view. They can have a steep learning curve for data professionals without a coding background, the metric side. So for example, I don't foresee I am comfortable writing YAML files, but I know that not everybody might be comfortable writing YAML files, especially if it's the first time that they write something or do something that seems to be somewhat related with coding. Complex feature creations in real time is still quite challenging. So for example, for what I've seen from Feast, it's very, very easy to get the access that you need to do online predictions. But the transformation side has an added piece of complexity, which is why there are paid solutions for this. Still early days, which means a lot of testing and development is still in progress for metric stores. It is easier for feature stores. It might be easier to adopt for big companies than for smaller companies. So let me pause there because it's very important to understand this. If you are in an online setting making predictions for users that have already signed off for your services, and you have to retrieve that data, if you just have thousands and thousands of customers and you have a model wrapped up around wrapped in an API, and say the application on one side facing the consumers is making a call to that model API. Well, maybe that call, or with that call, because you have new data coming in or a new action by that user, well, that might also be the job of that application to get the data from that user for the login, for whatever the data might be. So it might carry that information that we need for our prediction all together when it makes a call, when it sends a request to our API with the model. That is in a setting where you don't have thousands and thousands or millions and millions of users. If you have millions and millions and millions of users, and one of your users is just sitting in a database all the way to the bottom, or whatever it might be, that might be a much larger computation. So you might need a different way of accessing that feature in a close to real-time setting as possible. And now the differences between the three: batch setting, batch inference. So you're training a model based on historical data sitting in a warehouse, data sitting somewhere. Streaming, there's a fine line between streaming and on-demand or real-time. I think Chip Huyen, I am probably mispronouncing her last name, but Chip is probably one of the most prolific writers and ML practitioners out there. She has a very good talk from the Feature Store last year, and she says, or she described that a real-time prediction is between milliseconds and just a few seconds. So that will be considered real time. Once you go over, if you think on the streaming context and you have data coming in per minute or per 5 minutes or 10 minutes or an hour and stuff, that's still streaming, but it's streaming batches of data rather than real-time predictions. If you think about a stock exchange or something of that matter, or high-speed traders, they are trading at milliseconds or nanoseconds. So that is very, very real time versus in a minute, that is like a year in those terms, maybe. Maybe that's exaggerating, but I hope that paints a good picture versus on demand, like real time, milliseconds to seconds, streaming, maybe not necessarily milliseconds, but tiny batches within minutes, 10 minutes, 5 minutes, and so forth. And then batch data, historical data. Okay, so then the metrics, handling large data sets can be challenging. If you're accessing a ton of data via metrics layer, that might be a little bit slow. And then handling thousands of features might be a challenge. So instead of a lot of features or a lot of rows, think about like having thousands and thousands and thousands of features, because you have to set up this one manually in the feature store. So that might make it a little bit complex. All right, so some of the similarities, they both work best and are optimized for structured data. In both you can, but before I continue, I have seen uses of feature stores for embeddings, which is very, very cool. So if you don't know what embeddings are, but you've heard of transformers or you've heard of different architectures in the deep learning world. So what this means is that you have some sort of model, and that model takes on some data, it compresses it down to a smaller representation. Think about a compression problem, and then it decompresses it and it tries to get to the exact same output. So essentially, you're trying to sort of compress the information coming from your data into a small table, and that might be a good analogy to represent the embeddings layer. Tommy Jones said, "Embeddings is my jam." I love it. So I've seen use cases in the featurestore.org, which is the website for Feature Store, the Feature Store Summit. There's a couple of companies that have examples on how they tackle embeddings in a feature with a feature store. So that was very, very interesting. I think it was a little bit more out of my depth than my expertise, but it was extremely cool to see how people are coming up with clever ways to account for these embeddings. So in both, you can define things once and use them everywhere. You can update your definitions, and once the changes happen globally, then metrics and features can be backfilled. Then both act as a centralized repository of knowledge, and then both have interfaces similar to, or allow you to use them via interfaces similar to Jupyter Lab, RStudio, and so forth. Okay, so some differences. Metrics, this is very important. Metrics can be fed to a machine learning model, but not all features might be useful as metrics. So features actually might be completely meaningless as metrics, because if you think about it, if I have a categorical feature and I have gender or I have age, I'm probably going to get age and an aggregation of some value. Maybe the price spent by cohort, 20 to 25, 40 to 45, 50 to 55, and so forth. That is an aggregation, but that's going to be, so that feature, age, and that other feature, revenue, or some other feature might be meaningless as a metric, but a metric can be a source of information for a learning model. So that's an important difference between the two. Feature stores are optimized for online usage, while metric stores are mostly, they work in sort of a batch system. Metric stores sit as a layer between the data storage and any downstream tool, but feature stores, they work for and around the machine learning cycle. So they're sort of part of your pipeline, the feature store, while the metric store is just is there. It's a piece of infrastructure, kind of. The metrics tend to have a long life, shelf life, while features can come and go as the products and services of the company mature. Think about what we mentioned earlier about distribution shift. If something changes, that might change the way our model predicts or makes the next prediction. So we might be including back or taking away features that were in our model or were not in our model, respectively. So the last thing, metric store should support simple to complex metrics. while feature stores should make the simple ones easy to implement, iterate fast and effectively. And then a quick example of churn. So churn is defined in the metrics context is the rate at which customers stop doing business with us. In the terms of features and in the terms of machine learning context, churn is a 1 or a 0. So let's look at what that looks like. So we have here months of the year. We have the total maybe number of users. And then we have, the total number of users at that time in the platform. And then we have the churn users. So then in churn, the churn rate of that will be how many people left us on that month. But then in the machine learning, in the ML side, churn looks like this. Here we have, so here we have rows aggregated. We have the sum of the total users and the sum of the churn users by month. So we have an aggregation. And then we get a computation. We divide churn users by total users, and then we get a rate. But then in the ML terms, we want every single row to be its own entity, or AKA its own user. So then we have the total charges that we have charged that user, we have their tenure, we have their gender, their ID and whatnot. But at the end of the day, the churn is gonna be a 1 and a 0. Did this customer leave us or not? Which we don't want them, but we wanna know. So we're trying to predict who will leave us. So that's the difference between those two. And I hope that paints a good idea as to the differences in metrics and versus features and how they are useful for analysis or for machine learning purposes. So now for the last section here, so how do stores add value? What solutions are out there? And how do I figure out what to look for in them? So the value added, they sort of circle back to what we have been discussing this entire time. But at the end of the day, like you have a single source of truth for any downstream tool. You hand over with feature store, you hand over most of the feature creation process and serving to a single system. In the metrics, having a metric logic separated from your tools allows more people to focus on deriving insights from data. The feature store monitor distribution shift between training and incoming data. The metric store, they define metrics as code and make it so that changes to a definition have to follow software engineering best practices. So think about making a change to a YAML file that describes a metric or has the definition of a metric. You push that to GitHub, or you create a new branch, you define a new metric, or you created a new, or you had a new way of defining a metric. You push those changes and you have to submit a pull request. Well, a person on your team has to revise it. And then if that gets approved, you push it to your metrics catalog and everybody reuses your definition of that metric. So then it enables ownership of a metric. As well. And then also the feature stores, they have a lower latency between incoming data, its transformation, and its prediction. Okay, so what are our options? So for the metric stores, we have Transform, we have Metric QL, we have DBT. As of yesterday, which was the last time I checked, I looked at DBT's website and it didn't seem that their metric store is still out. I don't know that, but I did see that they might, that they are working on one. And it was also in a paragraph in Metric QL, in Metrics QL website. They were saying that DBT will come out with a metrics layer or a metric store. So that's why I put them here. And then there's Cube.js, the one that I showed the code earlier, which was sort of a combination of JavaScript with SQL queries and so forth. And then there's Supergrain. I haven't seen their product. I know they're out there. I know they just launched recently, or they might still be in beta, but they're also a metric store solution. And there's a couple more, but I didn't put them there. For feature store, we have HubSworks, which to my understanding, they used to be proprietary. Now they have it open source. They have open source their solution. It's a feature store sitting, if I'm not mistaken, on top of a Kubernetes. So yeah, so they now have an open source solution, and they have amazing talks actually about their feature store. So I highly recommend that you watch it. If you're interested, they're all on YouTube. If you're interested in this topic, Feast, an open source solution out there, created by Gojek, now freely usable by anyone. There's StreamQL, there's Databricks, they have their own solution. There's Cascada, which is, or Cascada, I hope I'm not mispronouncing that. They are based on real-time, or not real-time, but historical or time series. It's a time series based feature store, if I'm recalling correctly. Then there's Featureform, which I believe is the new company behind StreamQL. There's Tecton, And then there's Amazon SageMaker has its own feature store, and there's just many other solutions. I believe there's way more solutions for feature stores that there are for metric store now, right now, as of this moment. So yeah, so StreamQL is part of feature form, if I recall correct. So lastly, what to look for in either solution. So for metric store, you want, yeah, Chris said an Amazon SageMaker feature store. Yes, that is the one that I'm referring to, the SageMaker feature store. So by the way, there's an amazing video about how the feature store works from their previous reInvent from 2021 that I highly recommend you watch. So for the metric stores, the things that you want to look for: do I have a framework for defining features? Do I have a catalog where I can search for metrics? Sorry, for defining metrics. And do I have a catalog where I can interface with my metrics so that people that don't know how to code, or people don't need to know how to code, they can go and access metrics as well. And lastly, do I have an API to make calls from, say, a Jupyter notebook and then get the data that I want in a data frame and then build my dashboard, my dashboards, analyze the data, and so forth. Now, for the feature store, do you have a single feature definition for production and training? Do you have a distribution consistency guarantee between serving and training? I think I definitely, I kind of misworded this one. Distribution consistency guarantee is not necessarily a guarantee, but a guarantee that is watching the distribution between serving and training. So that's a distinction there. And then lastly, seamless integration between your online and batch serving. Cool. And then when should you adopt a metric store? And I mean, this is part of what we've been talking this entire time. And it's sort of, if you want to empower more people or your organization to take advantage of data, if different teams are making decisions based on the same metrics, but with different definitions, maybe you want to think of a solution that gives you the same definition across teams. And then lastly, if a lot of the analytics cycle is spent writing queries to get data, then get rid of that if they don't need to be writing queries for that. Give them a way to go straight from data to insights, at least in my opinion. When should you adopt a feature store? When ML is not a nice to have at your organization, meaning it is part of your organization. Maybe you will benefit greatly from having it from the start than from adding it later on as it becomes a problem, serving online. When online serving is a crucial part of your business, of course, when the number of features your models rely on is large, or when you need a way to mirror distribution shift between historical and incoming data. Okay, so to recap, metrics allow us to track what matters for our business. Features are the fuel for our machine learning models, and they often need reshaping before we get to use them. Metric stores provide us with a way to write, govern, and serve metrics in a common language. And then feature stores abstract away the reshaping of features while providing scalability in both online serving and offline training. If you need consistency and scalability, reusability, and performance boost in your analytics and ML operations, then adopt either or both. And then lastly, metric stores and feature stores, they're like the maestro or the conductor of an orchestra. While the musicians can still perform without one, you can only hope for good synchronization. So thank you very much, everyone. I hope you learned something today about metric stores and feature store, and hopefully get you excited about what they can offer to either your workflow or your organization. So if you have any questions, please send them my way. Yes, Mariah. Thank you very much.
Thank you, Ramon.
Not a problem.
Yeah, and Mariah, and any questions, please throw them in the chat. And great job, Ramon. Thank you so much for that.
Oh, thank you very much, Tom. My pleasure. And yeah, Chris, I agree. The Amazon SageMaker one it's a really excellent one as well, especially if you're already using AWS. It definitely makes sense to adopt it. Not a problem, Charles. Thank you very much. Thank you, Mariah. Thank you, Will. Thank you, Gregory. Awesome. Thank you very much. So Will says, do you need a data warehouse to have a feature store? You do need a place to have them. And usually you are going to be using these models in the cloud. So it makes sense that you are retrieving them from somewhere that is optimized for analytical purposes. So a warehouse will be the place to get them from. So for example, some of the examples in Feast are using BigQuery And I mean, it shows why it's so easy to connect the two with each other, because first of your data or your model is operating in an online environment. And if you're already in that same cloud environment, so it just makes sense to retrieve them from your, yes, BigQuery is fantastic. So it makes sense to get them from a data warehouse. Thank you, Katrina.
So, Ramon, I have a question for you.
Yeah.
So, when do you have a good sense of when an organization should start thinking about going from say like the manual collection of metrics in say spreadsheets or something like that to a more formalization within a metric store? Any sense of the inflection point of the organization?
Yeah, I would say I heard from a couple of blog posts and also from anecdotal evidence of people that I've talked to that track metrics heavily. Whenever you lose money because different teams have different definitions of metrics and you rely very much on them, that might be a good sign that a central place for them it's in place, that you should be looking at those solutions. So that's one. The other one is, for example, if you are a experiment heavy organization and all of your experiments are tied to a metric, so you might always want to have, you don't want to have people that are doing the experiments also interchangeably operating and getting metrics, while they can always, if they can always access them from the same place. So I know that companies that do a lot of experiments like Airbnb and LinkedIn and so forth, like they have their own solution. I know that other companies like Lyft or gosh, what will be another one? Stitch, they do a lot of experiments. I don't know if they have a feature store, sorry, not a feature store, metric store in-house, but I wouldn't be surprised if they did. Uber has just thousands and thousands of models in production at any given point in time. So they have their own solution and they open source it as well. And I believe, so they have, I might be incorrect on this one, but they have like a metric store that is just for their logs, like connected to Prometheus and Grafana, if I'm not mistaken. Then they have another one that is sort of for everything in the organization, which is called uMetric. But again, I might be not saying this correctly. But anyways, if you're dealing with a lot of teams trying to access the same information and decisions are made on that information, so you might want to think of a way of standardizing them, save time, save money, computing metrics, and be on point with the decisions.
Awesome, man. That's was a great answer, far more than I was expecting. I'm curious, just how did you personally get so passionate about this topic? It's not something that I meet a lot of people that are really like so well informed and so passionate about.
That's a great question. So I came to Australia to build a bootcamp in data science, and then while I was working on the last module, which was it was called software engineering, software design for data professionals, and it's basically taking models and putting them in production. One of the things that I noticed is like whenever you're showcasing how load balancing works. So you want to create fake data, send the traffic to an API, and see whether it starts when and how it starts slowing down, right? So then I realized, okay, so this is a particular use case when I am coming into an application for the first time, and I want to receive a prediction on, say, my cart before I check out. I want to see other items that are similar, so the cold start. I want to see other items that are similar to me. But what if I am already a consumer? Then they're going to need my data. They're going to need my information to give me a solution. So how do I show them what latency looks like when trying to get online predictions versus and how do I show them what happens when that is the case, and how do they solve it? So then I came across Feast, and then I built a very, very basic example on how that gets attached to your ML system and to your whole infrastructure. So that was the first side on that end. Then I saw like the explosion of feature stores and not just feature stores, but well, open source solutions and paid solutions. So that's on the feature store side. On the metric side, I mean, that is just a common theme among educational institutions, research, everywhere. So everybody needs to track something to know whether they're making progress or not. And then when I came across, so my courses all start with data analytics, then they move on to the deeper aspects of machine learning and production ready ML. So when I look at the feature store, when I needed to solve that problem, I'm like, okay, what is the same thing, but for the analytical purposes? And then I came across the metric store. I saw that there were a couple of open source tools. I got connected with Transform, and then, just went down the rabbit hole, learning more about them and how they work and how can people benefit from them. So it was more of like, it feels more like, instead of being a path of like, oh, there's a shiny new toy over there, it was sort of like, I was going to end up, to me, it feels like I was going to end up over there regardless, because of building educational content and working on the problem that I want to show my students before I give it to them.
Wow, that's great. So if there are no more questions, I guess we can probably wrap up here. Ramon, again, thank you so much for taking the time to present to us today, and a big thank you to everyone who came. We can't. Oh, Majid is typing a question.
Okay, yeah, we'll wait.
We'll wait on you, Majid.
Not a problem.
To finish the thought, thank you also to everyone who came. I mean, we can't hold these things if we don't have both speakers and an audience. So everyone comes together to make these happen.
Yeah, it's a two-sided marketplace. No problem, Paul. Thank you very much. And again, Tommy, met like DC, Data Science DC. Like I went to a couple of the meetups, to the coffee meetups. I went to some of the events while I was there. And like second day that I joined the community, I get a job. So I got connected to the people that would soon become my employer and move me down to Australia. So so that was pretty awesome. So it feels good to actually present for the first time for Data Science DC.
Yeah, I also got a job through a connection at Data Science DC. I didn't go to Australia. I went to Columbia, Maryland for a couple of years, so not quite as exotic.
But
great.
still, I mean, as long as you get connected, like the connections is what matters. Like you want to go to these places in person, even if you can in person, it's not the same online. And you still want to go, you still want to show up and meet people and try to chat with somebody and connect on LinkedIn, and then later on have a conversation with them.
Yep. Yeah. And we're basically global now thanks to the pandemic. So there's no need to be a stranger, except I understand the time change can make a big difference. But even when we go back to person, our hope is to remain hybrid.
Keep it blended. Yeah. No, 100%.
Yeah.
All right. So
all right. So I'll let you take on Majid's question there.
Okay. So both feature and metric stores are more of a management thing than a technical thing. Technically, both manage computations. Then the difference between them is semantic. The thing is KPIs and metrics can be easily expressed in SQL. However, features may need to be expressed in a programming language. Also, their output may not be human interpretable. That's probably fine because KPIs and metrics are attended by analyst types, while modeling is done by more programmer types like data scientists, statisticians, ML, and so forth. So KPIs need actionable metrics, and KPI optimization needs the ability to predict actionable metrics. Metrics prediction needs predictive models. Predictive models need features. No, that makes total sense, Majid, and you're absolutely right on what they do and what they're seeking, what their goal is. What I would say though is that the management side on the metric store side might be easier, or is slightly easier, because once you have it in a catalog, you can have other people that don't know how to code access them. But in the feature side, you always have a programmer first of having the definitions, the feature definitions, and then you also have a data scientist, interacting with them or building the system around your feature store. So you're coding the entire time, and you don't stop coding with the features. You can see a catalog with just several command line tools and several commands. You can see the catalog of your features, what is being tracked, what's happening everywhere, but you're still always writing code. But then on the metric side, that's not always true for the consumer of your metrics. But you're absolutely right on the last part, that KPIs need actionable metrics. KPIs optimization needs the ability to predict actionable metrics. So I thought that was very well put. And then metrics prediction needs a predictive model. So very well, you said it better than me. And yeah, that was the only comment that I have on the management side of things, that is slightly easier to some degree with the metrics than, and also you might have more analysts and more data professionals that know SQL than data professionals that know Python, and could come up with some Python code to put together a feature store around a machine learning workflow. So that's also a big discrepancy in the knowledge that you need for one versus the other. Calculation dependency. No, that's very important. And I highly recommend you to check out Transform's blog on how to define, how their feature framework works, because I've seen plenty, but the way in which you set it up, like here's my definition, here's my expression, here are the dimensions that I need, here's the table where you get it from. I mean, it's so human friendly, super intuitive. Even if you don't know YAML, like you're going to get that description. So yeah, DBT definitely does a great job with transformations. And I mean, like I said, it seems on their website that they will come up with a metric store soon. So I will definitely keep an eye on that. Check them out. Yes. Yes.
Is that the right link?
Yeah, that's the right one. Thank you, Tommy. Perfect. Awesome, but right. Fantastic point.
Great. Well, I think we'll wrap up for now. Yeah. But thanks again, Ramon, and thanks everyone for participating. And we'll have this video up on YouTube within a few days, hopefully, for those that want to relive it.
Awesome. All right. Well, thank you, everyone. Have a great rest of your day and take care. See ya.
Right. Bye, everyone.